So we'll have 3 sessions today. The first one will be about the introduction to the OceanPrediction Decade Collaborative Center and the Arctic Regional Team. The second session that will be shared by either Regan will be about stakeholder, relevant activities, and user presentation. Then we'll have a break. And we have a third session, which will be an interactive session that will be chaired by the technical coordinator of the OceanPrediction DCC, who is Enrique Alvarez Bahurel. So we're gonna start by Alison Clausen, who is working for the Intergovernmental Oceanographic Commission of UNESCO, and the first 2 presentations will be made by video. So maybe we can launch the first video of Alison Clausen.
So good morning, good afternoon, good evening to everybody. For those of you who don't know me, my name is Alison Clausen. I'm a program specialist at the Intergovernmental Oceanographic Commission of UNESCO, and I'm also the deputy coordinator of the UN Decade of Ocean Science for Sustainable Development. And I'm thrilled to welcome you all here today for this regional meeting for the Decade Collaborative Center for Ocean Prediction, which is so generously hosted and supported by Mercator Ocean International. I just wanted to give a few opening words about the decade as a start, where it came from, why we've embarked on this adventure, but also really the importance of ocean prediction and the particular importance of this Decade Collaborative Center within the decade. So the Ocean Decade, as we fondly call it, was really born out of the fact that ocean science and ocean knowledge are central to so many facets of sustainable development. If we're thinking about food security, if we're thinking about education, resilient cities, if we're thinking about renewable energy, ocean science and knowledge is needed for all of these facets of sustainable development. And the decade, which started in 2021, is now entering its 3rd year of implementation. And I think this centrality of ocean science and the need for relevant and timely science and knowledge on the ocean is really greater than ever. But the opportunities are also greater than ever. You know, last year it was called the Super Year of the Ocean. There were numerous global conferences and meetings and convenings. This year there have been incredible advances in terms of new agreements and advances on the negotiation of a treaty around plastic pollution, around biodiversity in areas beyond national jurisdiction. And there's, I think, a really strong and growing awareness of the importance of the ocean for climate, for biodiversity action, and for human health and well-being. The work of the high-level panel for a sustainable ocean economy has really encouraged governments and other partners around the world to really start acting and develop tangible and actionable commitments and engagements to sustainably manage the ocean. So the Ocean Decade is part of all of this. It's part of these opportunities. It's really a rapidly growing global movement that's playing an increasingly important role as the engine of ocean science and ocean knowledge to feed these initiatives. For those of you who know it, I'm sure many of you do, the vision statement of the Ocean Decade is the science we need for the ocean we want. And the decade is structured around 10 Ocean Decade challenges, which range from marine pollution to ecosystems to the ocean climate nexus to sustainable blue food, but which importantly also look at some of the key pieces of infrastructure, the Ocean Observations Network, looking at digital infrastructure, the pieces that we need to be able to meet some of these big challenges. And of course, ocean prediction is really central to all of this. The Ocean Decade has grown rapidly since it started, which, as I said, was in 2021, and it's really been wonderful here at the IOC of UNESCO, which leads coordination of the decade, to see that growing momentum. There are now 48 global programs. We just had our 48th program endorsed. They're working across all 10 decade challenges across all ocean basins. But there are still notable geographical gaps in leadership. There are challenges in getting skills, access to partnerships, access to data, access to technology in least developed countries and small island developing states. And that's why, you know, one of the reasons why we applaud this initiative of Mercator through the Decade Collaborative Centre to set up these regional hubs, because it's so important to be able to translate the global ambition of the Ocean Decade to the regional level and start filling some of these geographical gaps that we're seeing in the Decade ecosystem. So these 48 programs, we also have close to 300 projects now. And if we're going to achieve the stated aim and vision of the decade to have the ocean we want by 2030, we're going to need massive amounts of coordination to ensure that we really are having a collective impact. And from the outset, the Ocean Decade was structured within UNESCO to have a very light and central coordination structure, but the aim was really to rely on partners with deep thematic and regional expertise and networks to take the decade to a level where impact could be achieved. And Mercator Ocean International was one of the first partners to rise to this challenge via the establishment of the OceanPrediction Decade Collaborative Centre. And I think it's fair to say that Mercator has really become a model for others to follow through the innovative approaches that they're using to regional engagement, community creation, knowledge sharing, catalysts of partnerships. And IOC-UNESCO and the Decade Coordination Unit sincerely thanks Pierre, Enrique, and the whole team for their leadership and engagement in this regard. Now, Mercator is not alone. Other Decade Collaborative Centres, Decade Coordination Offices have been emerging. We now have Decade Coordination Offices focusing on ocean observing and data sharing, and both of these are actually housed within UNESCO itself. And so in this way, the OceanPrediction DCC of Mercator is really able to play an even stronger and more impactful role by working with these other Decade Coordination Offices along the whole ocean science value chain. 2024 is going to be a critical year for the decade. It's going to come fast. We're already very, very close to midway through 2023. The 2024 Ocean Decade Conference is going to be a seminal moment for the decade. It's going to take place in Barcelona in April, from the 10th to 12th of April 2024. Pre-registration has opened, as has the call for satellite events. So have a look at the Ocean Decade website and find out more. And that Ocean Decade Conference, of course, is going to be an essential part of the preparation for the 2025 United Nations Ocean Conference. With the support of Mercator, the DCC and other partners, we hope that the ocean forecasting and prediction community is going to be able to really seize these opportunities, these events, these major global convenings that are coming up, to grow and to continue to catalyze new and innovative partnerships and sustainable development solutions. So having these discussions like today at the regional level is going to really ensure the relevance, the uptake of the results. And this meeting is so important. I wish you all wonderful discussions. I wish I could be there with you in person, but unfortunately I'm traveling and I'm committed elsewhere. But I really look forward to continuing to collaborate in the framework of the decade with the team at Mercator, with the Decade Collaborative Centre, and with all of you to collectively achieve the vision of the Ocean Decade for the ocean we want by 2030. Thank you very much.
Thank you, Vincent. So for the second intervention, we also have a video of Pierre Bahurel, the director of Mercator International. If it's possible to share the video.
Dear colleagues, dear friends of Ocean Prediction, I am Pierre Bahurel. I'm the Director General of Mercator Ocean International, which is the organization that has been entrusted by IOC-UNESCO for the implementation of Ocean Prediction DCC. I'm fully convinced that this is timely, this is necessary to deliver as one community, worldwide community for ocean prediction. And we were ready with Enrique Alvarez, the technical coordinator of the DCC, to fight for this, to work with you. But we were not prepared to receive such a response from you, from the community, about the appetite for doing more. So yes, we will do that. I have the feeling, and more than that, that there is something happening in our community of ocean prediction. Political leaders, they have decisions to make for the ocean, and they turn to us. They are looking for the data. They are looking for evidence. They are looking for this digital oceanography, the modeling, the prediction, to explain more. And we are there, and we are ready to deliver. And we are more impactful than we think and more organized than they think. So this is exactly what this Ocean Prediction DCC is about. Organize our community, make it clear, visible, and impactful, and be ready to deliver as one at the end of the decade. But we will do more, and every year we will deliver, and we can trust Enrique for this to steer our group to really deliver. And this year we want to deliver two things: a map and a plan. A map to put each of us on the map and be able to identify who is where and what are the best practices for your region, to share them with the other region. And the plan to explain what we want to do all together, the standards, the technical background that we want to share, and how we will deliver as a community. A map and a plan. And something which is very important is that this Ocean Prediction DCC is a collaborative center. It means that this is a bottom-up approach. We will work from the programs of the UNDK, this fantastic momentum that has been creating with programs that are gathering the projects and the actions. So we will play with the program leaders and the teams to identify what is mature to organize this community. And we will play with the regions, with your region, because we do believe that the best experts in your area are you. So we want to understand from your region what can be shared with the others, how we can work together to deliver as one in this Ocean Prediction DCC. So I wish you the very best for this meeting, and trust Enrique for the rest of the meeting. Thank you very much.
Thank you. I want to let you know that the meeting is recorded, and that if you have any question, there is a Q&A box, so you can use it. The next presentation will be done by the technical coordinator of the Ocean Prediction DCC, Enrique. And is going to give us an introduction of this collaborative center.
Thank you very much, Barbara. And I will share my screen now to share with you my view on what are we trying to do with the Decade Collaborative Center. So I hope you can see the screen correctly. And
yes.
First of all, I would like to explain where we are in the framework of the decade. This is my interpretation of the decade implementation plan. This is what is wrote there in a simplified form. We have basically two boxes here. One is about governance and coordination. This is the governance and coordination framework, where we have two main elements. One is the decade coordination unit. These are the boxes of the decade, the IOC-UNESCO leadership. Here is where you can find Alison, who kindly prepared for us the first speech. And then we have the different decade collaborative centers and the decade collaborative offices. There is not a big difference between these two, so for the sake of this conversation, we will treat them equally. And these bodies are about collaboration, monitoring, and coordination, and they are talking with the programs that are here. You can find here the very well-known names such as 4C, DITO, OceanPredict, OBPS, all these programs that you are all aware of. And the idea here is that the DCCs and the DCOs have to somehow manage, monitor, and catalyze the coordination of these programs. So at the end of the decade, the result is something consistent, something coherent, and something that will last beyond the decade. So how we are going to do that in our particular field of action? Our particular field of action is ocean prediction. So how we are going to face this in the framework of ocean prediction? So to understand this, I have prepared this slide, which starts with the ocean forecasting we have today. You can see that we have just a few centers. We have more than a few, but we don't have so many centers beyond in countries that are technologically less advanced. And on top of that, those systems are not connected, are not delivering as one, and there is not a community supporting these people. So it's very difficult to implement new system, to operate new system, and to deliver as one, because we don't have this structure. So what we want to move is to a new scenario where we will have systems that will be much more easier to implement, and they will be using common tools, so they can deliver as one. So they are, let's say, in a technical community integrated. But apart of that, they will be in a human community. So the community will be there to help, to support, and to build together. So more connected systems and many more robust systems worldwide. So how we are going to try to do this challenging transformation? Well, the idea is through this opportunity, which is the ocean decade. That's our captain in this analogy with a vessel. Then the actions will take place basically on the programs, and we are going to take advantage of the arrival of the concept of the digital twin. The crew, it will be us, it will be this community that we are building. This meeting is about building this community in the Arctic, and our role will be setting the course from here to here. So this is our role. Our main role is to serve as inspiration for the community to move from this scenario to this other scenario by the end of the decade. So we have two pillars to achieve this challenging and ambitious transformation. The first pillar is the regional teams. The regional teams, and this is the reason of the meeting today, to have the first meeting of this Arctic regional team, are going to be promoting the implementation and use of ocean forecasting systems worldwide. And we are building on the existing communities. We are taking the best from UNEP, we are taking the best from regional alliances, and with that we are building our own regional teams. So once this will be, the idea is that we are forming these teams and they will be completed by the end of this year. Once they will be formed by the end of this year, this will be our boots on the ground work starting this year to identify and attract this wide community. We are talking not only, we are thinking out of the box, we are not talking about our usual suspects, the scientific community, but we want to go beyond that, and we want to involve the private sector, we want to involve non-governmental organizations, the user, etc. So we want to build a larger community of everybody talking to each other. We want, obviously, because it's in our reason to exist, to support the decade action related to ocean forecasting, the ones that I mentioned previously. And we want to do a series of works in identification of gaps and way forward. We want to work on capacity building, and linking with my explanation of the second pillar that will come later, we want to advocate for the implementation of best practices, standards, and tools that permit us to do this transformation from one scenario to the other. So how are these regional teams organized? So these are organized by region. We are in the Arctic, so this could be Arctic or this other one. And we will have two main components in each regional team. A focal point that here is led by Heather as chair of the regional team, and a steering team that will form by a series of specialists. In all the regions, we have the same positions, we have the same specialists. So at the end, all these specialists will be able to talk to each other and will be able to create a worldwide network of specialists in the different topics related with ocean forecasting. So this is the idea of the governance of the regional team. So this steering team, why is it so important? Because it's going to be a global network of topic experts with focus on many different things that we are going to start working starting next year. First of all, provide new ideas, because we will have a great number of relevant experts that could feed us with ideas on where to go. Act as focal point for that region, for that particular topics. If we have an expert on biogeochemistry, he will be our focal point if we want to deliver some activity related to biogeochemistry in this region. And all these other activities which are quite important. Network with other region experts, as I mentioned in previous slide. Support the mapping of ocean forecasting. That's what Pierre was mentioning, to have this map on how ocean forecasting is implemented today around the world. Support the gap and need detection activities. Contribute to the communication and the forum. You will have later some explanation on how we are advancing in building our webpage and our tools, the map, the forum, the communication tools, and we will need your support to manage all these tools and to make this a lively place, to make this forum something really interesting and something that has to work. So we will that will be an important support that we will need there. Then contribute to expand the community and support the capacity development and ocean literacy activities. So this is how we are advancing with the different regional teams today. As you can see, we are with the objective of having all this, let's say, in black by the end of the year. We are advancing, I think, quite well. Some of the regions, the complete work is done, and they are more or less waiting for the others to finish so we can start to get the activities. We have West Pacific and all the Asia part is done. Africa is advancing also very well. Arctic, thanks to Heather. Thank you very much, Heather, for all the nice job you have done pushing forward in this. Thanks to Heather, we are doing very well and we are one of the most advanced. Just a few places are missing on the steering, but that will be solved soon, I'm pretty sure. And the other ones are advancing a little bit more slowly, but we are having recently very good advances with South and North America that are the one maybe having a little bit more of delay. So situation is going very well towards this objective of having this community formed by the end of the year. And remember that almost 1,800 people registered on the kickoff meeting. That's what Pierre was talking about. A huge interest that this has honestly surprised us on the community, because there's an anger, there's an appetite for this idea. And this is pretty obvious in every activity we do. The second pillar is the technical pillar. We were talking about the systems that have to be connected. The problem is that the systems are technically disconnected. This is what we want to face. That means that during development, if you are in, especially if you are in a less technically developed country, you are basically starting from scratch. So you don't have the right tools, standards, and best practice to develop in a safe way. And if you are able to develop, your problems are not ending there, because during exploitation, you don't have possibility to use common tools for validation, dissemination, and exploitation. So the opportunity here is the decade as a game changer, and also the arrival of the concept of the digital twin will help us with all the interoperability questions. And the first step we are giving here is the creation and the launch of the Ocean Forecasting Co-Design team. This is a group of experts that we have created, and this group of experts will deliver, hopefully by the end of this year, a new architecture. By new architecture, we understand which are the tools, standards, and best practices that will be needed to be developed during the decade in cooperation with related decade programs to change from one scenario to the other. So here we are basically doing the map. This is what Pierre said, that's the plan. We are building a plan on how we have to move from one scenario to the other. So the results are to inspire decade programs development targets. Hopefully, they will be able to collaborate with us in building this plan. So, as conclusions, we want Ocean Prediction DCC to be a key element for the ocean prediction we need. We are building on an active community of users, scientists, and policymakers, and we want to make a special focus on developing countries, because this is where the real need is, and we will have a more visible change soon acting there. Nevertheless, this applies to everybody. We will take advantage of the decade framework and the arrival of the digital twin of the ocean concept to join and deliver together. This is quite ambitious, so even if we only succeed partially, substantial benefits are expected: a better connected community, new and more robust operational forecasting services, and a technologically linked worldwide ocean forecasting framework. We are aware this is a significant challenge. We are aware this is quite ambitious, and it will be only possible in the framework of the decade, thanks to the collaboration with all of you and the collaboration with the decade programs and other relevant actors. So this is why our motto, I think you can understand now why our motto is connecting the world around ocean prediction. And this is it. From my side, I give you back the floor.
Thank you, Enrique, for this introduction.
You're muted.
You sure?
No, it's okay.
Okay. So now I'm going to give the floor to my colleague here in Mercator, Romane Zufic, who will introduce the tools that the Arctic team members will have access.
Thank you, Barbara. Hello, everyone. So indeed, I will present to you today what we call the ocean prediction tools, which is all the tools that will be available on the website to connect this community, to offer a place to meet, exchange, and learn about each other. So first of all, the website will be officially launched in September, and we will do like a silent launch, let's say in July, to start putting everything on the map and putting everything in order. And on this website, we will have several tools that I will present you during this short presentation. So the atlas, the forum, a news and event place, and resources that will be available. And of course, if we want this to be the place to gather the community and exchange, the participation from the community is vital. So we are really counting on you to launch the regional team of Arctic in this website as well, and to be active members. So first of all, the atlas. So this will be a place to identify our community. So we will have 4 different atlases. An atlas to identify the operational ocean forecasting system. So it's a world map with pins of ocean forecasting system, of individual, institution, and also downstream services. So this will be more than just a simple directory. It will be really a place where we can find information on the different activities, potential partners, existing institution. And we will have this interface to allow the community to add and modify the information, to link themselves to an institution, to link a system to an institution, and only registered member will have access to other people's information. So it's really something to help people to connect. So here is just a preview. This is a preview of, so it's only a mock-up for now, which might look a bit different, but essentially it's like this. This is the atlas of the ocean forecasting system. This is the atlas for the individuals. When you click on one person, or either on the list or on the map, you have this pop-up opening with some key information about this person. And then we move on to the forum. So if before it was the place to meet each other, this is the place to exchange. It's really the focal point for communication, and we aim to do some matchmaking and to organize this in cooperation with other Decade Action. And for this, we will have multiple channels and topics. So we aim to share community announces and have a place for matchmaking. So either connect people, like put some job opportunities, some research opportunities, and information like these ones. We aim to announce about ocean forecasting activity that relates to the Decade program, that relates to the regional teams. And also we want to have a technical forums for special announces and doubt solving. So really place where we can discuss some doubts and specific things on different models, for example, and all of this. And we aim to have different people administrating different part of the forum, especially, for example, we will have different, like a channel dedicated to each regional team. So we aim to give to each regions the opportunity to manage their own channels. So here on the side, you can still see how it will look like. So this is a different ticketing channels that are open, but mostly here on the left column, you have all the topics that will be opened. So it's really small here, but it's just for you to understand the mapping of the different channels. And also we will have, as I said before, the news and event page. So this is the place to get in touch and to learn what's happening from one region to another, from one center to another. And we really want to have here to reach a very wide audience, from coastal to deep sea. It's from bio to physics, public to private. This is really supposed to be the place where you can have access to all information. And as information, we aim to have also news from the regional team. So periodically information of each regions, similar for the Decade Action as well. And one main resource that we will have available on the website is the ETUV guide that will be turned into wiki. So first of all, the ETUF guide as it is right now will be fully available. Each chapter, you can download the full document, or each chapter depending on your needs. And then we really aim to convert this into a wiki, so making it available for editing for all the members. Of course, we will have a moderation, but the idea is really to ask everyone to contribute to build this document and to really go further into putting all the knowledge together. And in that sense, we aim to have every 3 or 4 years the publication of the next version. And for the editing, we will start by adding new section on biological modeling and tsunami. And so we really want to target the right expert to really help us to build further these comprehensive documents. Last, I think we will have the virtual host. So if you attended the kickoff in January, you may remember that we did some virtual hosts. So it was an exhibition, and we really want to continue this work further by providing information and some visibility for each operational ocean forecasting system registered, and also to highlight some downstream services and some UN decade actions. So yes, I think that's it for the start of the website, and we really want to have everyone involved at every step of the way. Thank you very much.
Thank you, Romane. Next, we'll have Eva Regan from the Nansen Center, and she will introduce the steering team.
Yes, hi everyone. I'll just give a very brief introduction to myself. Firstly, thank you very much for attending this meeting and being part of the Arctic regional team. Obviously, this work won't be able to be done without all of you. So a very brief background of me. I did my PhD in 2017 in Antarctic physical oceanography, which was a modeling PhD looking at regional sea in Antarctica and focusing on freshwater. I then moved to France for my first postdoc and looked at the Arctic, again in terms of freshwater, in particular the Beaufort Gyre. And since 2020, I've been based at NERSC in Bergen, Norway, and I've been focusing on Arctic sea ice modeling, doing various things, mostly multi-year ice modeling and ice-ocean coupling. More recently, I've had a little involvement with the NERSC forecasting system here. So my background has been in polar modeling, but more on a large scale until recently. The reason that we are involved here at NERSC, because it's me and also Laurent Bertino is supporting me a lot in this role, who's an expert in data assimilation and was also leading the Arctic Marine Forecasting Center. We have an involvement in this work because we have 2 of the available Arctic forecasts here at NERSC, one of which is the TOPAZ system, which is a sea ice, ocean and biogeochemistry system, and also the standalone NERSC sea ice forecasts up to 9 days ahead. And these are both available on the CMEMS platform. So we have these forecasting systems in-house, which gives us a good position to have an awareness of the forecasting systems in the Arctic so far. So what we've been doing so far, as mentioned by Enrique, there are 2 pillars. The main one that I am involved with, and as at NERSC, the community pillar 1, which is involving the Arctic regional team, so you guys. So I've been involved with gathering the regional team, and we are keen for more people to join this. So if you know of anyone who you think would be relevant to assisting with our efforts in the wider regional team, then please let me know. My email is at the bottom. And I've also been involved with creating the steering committee, which I will show on the next slide. My other work so far has been involved in the second pillar, which is the co-design team. This is a team of technical experts, as explained, who are advising how to move forward with this global network of forecasting systems. And these, as well as these technical experts, the chairs of the regional teams are feeding information into this pillar in order to help advise. And this is very useful for the Arctic, which has some quite unique forecasting challenges. So currently we have been, as regional chairs, providing short reports on the current state of forecasting, in this case in the Arctic, the gaps that we perceive and ways forward. And the first short report has been submitted. The second one is in progress, so we're working on the gaps at the moment. And the last discussion of the day will involve having some inputs from you about this. And these inputs are very valuable. There's a short reports at the moment to feed into the technical team, but we will be expanding on these ideas down the line over the coming months more in the pillar one sense. So now to introduce the steering committee. I won't go into details because I have let the next space be available for the experts to introduce themselves. But I would just like to say we're very happy with the committee that we have so far. Everyone is a very valued member of the community, and I think we're very lucky to have them. So thank you very much for committing your time and energy to this. You will see in red there are a couple of vacancies, which we are still on the hunt for filling. So again, if anyone has any suggestions, please bring them up later on in the discussions or email me after. Yeah, great. Okay, so at that, I will pass back to Barbara and allow the steering committee to introduce themselves. Thank you.
Thank you, Heather. So now I'm gonna give the floor to talk about ocean observing to Carolina Gabarro, Michael Karcher, and Franck Kauker. And I'm very sorry if I misspell your name.
Hi, everybody. Can you hear me?
Yes.
Okay, good.
We can.
Good. I'll present the work we are carrying out in our research center. I am Carolina Gabarro in the Institute of Marine Science, and we are in the team of the Barcelona Expense Center on Remote Sensing. We are working on remote sensing data since the beginning of the BEC. It was almost 20 years ago. And I'm the leader of the Polar Research Group. Oops, sorry. I should start here. Sorry for that. The Polar Group, we are mainly working on producing research, remote sensing data, and also doing some research and development. The Polar team are these 6 people from here. We have 2 PhD students, 2 postdocs, 2 permanent research people. And we started and we are mainly focused on working on SMOS, ESA satellite data. SMOS is soil moisture and ocean salinity mission that measures, as said, the salinity, C-surface salinity in the ocean, and also the thin ice thickness. We also work with spectrometry, imaging, hyperspectral imaging satellites with altimetry data, and we are also working on the future missions for CIMA and some Earth Explorer 12 proposals.
Just Carolina, I just was wondering if you were using slides because we cannot see slide. If you have no presentation.
You cannot? Sorry. Yeah, I was presenting.
Okay.
Sorry for that.
It was
Thanks for telling it to me. Okay.
Normalmente you
Sorry
have.
For that. Can you see it now?
Yeah, it's working.
Good.
Thank you. It's perfect.
This was the first slide. Here is the team that we have. And I was going to explain this slide, saying that in the production of remote sensing products, we are working very much, and Arctic, we are working very much in producing quality and high resolution product of sea surface salinity of the Arctic, which is very challenging because the cold water puts special challenges for deriving the salinity from the satellite measurements. And I want to show these figures because we had a project with ESA in which we produce an enhanced salinity product. And in fact, NERSC and Loren Bertino were in this project, ESA project with us, and they assimilated the product into Topath reanalysis model. And in fact, we show that it's producing a better output. Topath is producing better output thanks to assimilating osmosis. We are also working producing thin ice thickness maps. We are working producing new maps using machine learning algorithms, and also we are working improving the sea ice emissivity model, which is needed for producing these maps. About the oceanographic studies we are working on, we are seeing and detecting freshwater lenses with osmosis due to the melting. We also are observing the melting from Greenland. We combine salinity and CDM satellite data in the river mouth. For example, this is the Russian river, so we can infer one variable from the other, or we are fusioning them to have enhanced resolution. We are studying the freshwater budget in the Beaufort using Topath or using osmosis chop first layer data, and also we are working on classification maps. Just to say that we have been working in several European projects and national projects. European, we've been working in Kepler. I was leading the chapter identifying gaps and limitations of the polar satellite product. And we finally published this article, which is identification of gaps that we have seen for monitoring the polar regions with remote sensing data. I'm working also on CRISIS satellite, Horizon 2020 project, and we have been working in many tenders, ESA tenders for osmosis and also for the future CIMA mission. And that's all. Thank you.
Thank you, Carolina. So, Michael, I see you turn your video on, so I give you the floor.
Yeah, thanks a lot. Yeah, I have no presentation on my own background. I will give a short overview on Arctic Passion Project very soon. So I skip a presentation here. My educational background is I'm a physical oceanographer working at the Alfred Wegener Institute for Polar and Marine Research in Bremerhaven. I am the chair of the ASOF program, which is the full name is Arctic Subarctic Ocean Flux Study, and this is a forum or interest group which comprises all major gateway mooring teams around the Arctic and captures the exchanges in the ocean between the Arctic basin and the subarctic basins, plus a lot of teams which work in the basins themselves. I'm also the scientific coordinator of the Arctic Passion Project, and I will say a few words about that later on, but basically it's dealing with improving the Arctic observing system, and therefore I think it has a very interesting relation to the plans which were presented here in the first presentations. I'm stopping there.
Thank you, Michael. Franck? I give you the floor. Hello.
Yeah, I'm Franck Kauker. I'm working as Michael at the Alfred Wegener Institute of Polar and Ocean Research. Sorry. We are both part of the CI section, and in the CI section at AVI, a lot of observations were taken, remote sensely, or are taken remote sensely, and in situ, all connected to sea ice, but also snow in both hemispheres. My background is more modeling. I made my PhD at the Max Planck Institute for Meteorology, so my background is climate research. But at AVI, I was more concerned with regional modeling, and in later years I started to do assimilation. And for instance, in the project Arctic Passion just mentioned by Michael, I'm responsible for a work package that is dealing with network design. So we are using models to design better networks of observations, or help to design these. Of course, in theory, it's easy to say that, but in practice, it's rather difficult to do that. But we are aiming to get some reasonable results there. That was all I wanted to say. Thank you.
Thank you, Franck. So now I'd like to give the floor to Til Rasmussen to talk about ocean physics and connection with users.
Yes, thank you. My name is Til Rasmussen. You can see me. I don't have a presentation either, but I will say a few words about what DMI is doing. I'm sitting at the Danish Meteorological Institute, and then a few words about myself. And first, DMI, we are essentially doing everything from in situ observations through modeling on different timescales to remote sensing, and especially the remote sensing products for the Arctic are part of the Copernicus system. And as one of the obligations as the National Meteorological Institute is that we need to provide warnings to mariners in Danish waters, which includes Greenland and Faroe Islands. And therefore we have been engaged with users in these areas. Right now we are running a test on sending automated ice charts to ships through different channels than internet channels. It's a follow-up to the AIS system. And for myself, then I've been working on in the modeling world, primarily on short-term forecasting of ocean and sea ice. The focus has again been on the primarily Greenland, and we've been doing both regional modeling on a large scale of the entire Arctic, but also of fjord systems and area around Faroe Islands in different studies. And I've been working at DMI for around 10 years, I think. Yeah, I think that was it.
Thank you. Thank you, Til. The next presentation going to be on ocean physics and made by Gregory Smith from Environment Canada.
All right, thank you very much. You hear me okay?
Yeah, perfectly.
Yeah. So I also do not have any slides, but I'll give you a brief overview of my background and activities. So I'm a physical oceanographer as well, and I did my doctorate on some observation and modeling in the Gulf of St. Lawrence in Eastern Canada. And it's often a region we refer to as a kind of a mini Arctic, a lot of the same sort of processes and interactions that we see in the Arctic. So it's a nice reference. So I'm currently working at the Canadian Centre for Meteorological and Environmental Prediction, part of Environment Canada in Montreal. And there I lead the Ocean Prediction Research Group, where we work on sort of a variety of different systems that we've been developing. I have a hierarchy from global systems that support medium range out to seasonal forecasts, to regional systems, cover the 3 oceans around Canada, and now to coastal systems on the east and west coast. My particular interests are really in ocean data assimilation, the modeling, and the coupling to the atmosphere that we have in many of these systems. Some of the important clients of these systems include both the numerical weather prediction groups that we work closely with in terms of improving the interactions, the air-sea ice interactions to improve the weather forecasts. But also we provide services to the Canadian Ice Service, and in particular for the sort of 2 pie slices north of Canada as part of the GMDSSS Met areas 17 and 18. We also provide support to environmental emergency response, so for oil spills, to search and rescue activities through the Canadian Coast Guard, and things of that nature. A few of my sort of other international activities, just want to mention, I'm also co-chair of the Intercomparison and Validation Task Team as part of OceanPredict. And not to be confused with OceanPrediction DCC. And so one sort of important activity there is we run a near real-time intercomparison against in-situ observations and satellite observations of various different ocean prediction systems. And we also include the Arctic in that. And sea ice is one of the variables that we use as well. So that's sort of an interesting reference and perhaps useful in terms of helping to tie together different modeling and prediction activities. I also want to mention that so over the past sort of 10 years or so, I was on the steering group for the Polar Prediction Project and the associated year of polar prediction. And so that was, you know, I think a really interesting activity that in a way sets the stage for a lot of what we're looking at here. The focus at certainly more of an NWP aspect to it, but also included coupling and kind of environmental picture and a lot of sea ice and ocean activities were part of that. And so I think it'll be very interesting to see, you know, how we build things going forward, and perhaps can leverage off of a lot of the things that we learned and developed as part of the year of polar prediction. So I'll end there. Thanks.
Thank you, Gregory. The next presentation will be on ocean biochemistry and made by Takuya Nakanowatari. So if you are able to connect, and by Annette Samuelsen, also from the Nansen Center. I'm not sure she's online, so maybe if she's connected, she can turn her camera on.
I'll give a few words about her afterwards. She was unable to make it today, but I'll
true. That was Annette. Sorry. Okay, perfect. So Takuya, I give you the floor.
Okay. Can you hear me? Hello. Hello,
Yes.
everyone. Today I also have no specific slide for my introduction, so I just talk about myself. So I'm hello. My name is Takuya Nakanowatari. My research institute is Fishery Oceanography. The name is Japan Fisheries Research and Education Agency. So I'm a physical oceanographer specialized in polar and subarctic research with special focus on the importance of ocean circulation, sea ice processes, and the role of polar ocean on ocean climate and biological systems. So so far I have worked for many years in data analysis and numerical modeling study based on ice-ocean coupled model for aim of clarifying the cause of the internal to decadal scale variability of ocean environment and material circulation in the North Pacific, including the Sea of Okhotsk and Bering Sea. So our research group developing I'm sorry. Now I'm mainly engaged in the development of operational ocean forecasting system in the North Pacific in our institute, which is named by Furaloms 2, and also are working on repeated hydrographic observation in the Kuroshio-Yashio confluences. This observation repeat hydrographic observation has continued since 1987, so it's a quite long-term ocean monitoring system. The obtained data is used for the assimilation data for our data assimilation system. So now our operational forecasting system provide real-time information in your website. So you can so is it? And I'm trying to share our website.
If you wish, you can share the link on the Q&A section.
Okay.
On the panelist discussion, and I can share it afterward with all participants.
Okay. Okay. Now I share the website. Is it possible to see?
Yes, we can see the screen.
Yeah, I'm sorry for this slide. Website is written in Japanese, so but you can see the feeling of the operation forecast system, the website. So this information is mainly used for the fishery industry. And also this data set is used for the research for fishery resources in our country. So based on my knowledge of this operational forecasting system and also ocean monitoring, I would like to contribute to the Arctic Steering Committee. Thank you.
Thank you. So maybe if you can stop.
Yeah. I tried to check.
Perfect.
I mean, that's okay. Okay. Thank you very much.
That's okay. So either I give you a phone instead of Annette.
Yes, okay, so I am not Annette, but she does work here normally. She's on holiday at the moment. So Annette Samuelsen from NERSC will also be assisting Takuya with the ocean biogeochemistry expertise role. She has been the head of the ocean modeling group here, which has a lot of experience with modeling different timescales, and it uses HICOM with eCosmo biogeochemical model, and the forecasting system Topaz includes that as part of the outputs that are available on the Copernicus website. I won't go into any more details about Annette because she can introduce herself next time, along with the other positions that hopefully will be filled by then. But yes, we're very happy to have her and Takuya working together on this. Thank you.
Perfect. Thank you, Heather. So the next presentation will be on ocean climate and made by Amy Salomon. I think she's connected.
Yeah, I'd like to share a few slides.
Perfect. So it's working. Perfect. That's working.
Okay. So yeah, I'm Amy Solomon. I'm a senior scientist at the University of Colorado in the NOAA Physical Science Laboratory in Boulder, Colorado. And my role in this steering team will be to represent ocean forecasting from a climate perspective. And I just wanted to highlight a few of the leadership roles that I currently have been involved with. The first is to co-chair the CLIVAR Northern Oceans Region panel, which is a relatively new panel within the whole spectrum of CLIVAR regional panels. And it serves as an international forum for coordinating and strategizing the activities of the role of the Arctic Ocean in the context of the global climate system. And two activities that we were recently involved with that I think are relevant to this group. The first is we coordinated a CMIP 6 boot camp on Arctic processes for early career scientists. And we also had a workshop on the role of freshwater and the future evolution at high latitudes, which was coordinated with both the Northern Ocean Region Panel and the Southern Ocean Region Panel, which was really a fabulous way to really look at the different processes from a climate perspective, from a polar perspective, and how they differ from the Northern and Southern hemispheres. And that will continue as a summer school next year. The second activity is I was co-chairing the WWRP, the Polar Prediction Project, which Greg Smith mentioned, the Sea Ice Task Team. And one of the activities that came out of that was to develop the Sea Ice Drift Forecast Experiment, or SIDFEX, which has been really fabulous at providing a community effort for forecasting sea ice drift and using it both to evaluate model biases as well as to support observational campaigns. And the third thing is I was the international lead for organizing the forecast guidance in support of the Mosaic campaign, the year-long drift experiment that took place between 2019 and 2020. And I also led the evaluation of a number of different forecast systems after the campaign. And then I just want to show a few slides of some of the activities that we're doing in our lab at this time. Oops. The first is we developed a fully coupled Arctic forecast system called CAFS. And it was developed from the NCAR climate model, which is relatively high resolution, 9 to 10 kilometers, with ocean, ice, atmosphere coupling. And we're using this model both to support the National Weather Service. So we provide these forecasts daily. This is just an animation to show how important it is on even daily timescale to provide the coupled information, how quickly this black line here shows the sea ice edge and how quickly it changes on daily timescales and the impact it has both on the atmosphere and on the ocean. And so we provide these daily. We have a web page that provides images and output that a number of different centers are using for guidance for their forecasts. We also provide these forecasts to support observational campaigns from drift experiments to ship-based campaigns to aircraft campaigns. This is for the Navy. We support the Navy campaign's ICE-X, which happens every 2 years, where they provide candidate ice flows, and we provide drifts to both help them decide which ice flow to put their ice camp on, and also to provide alerts if there's any potential for leads opening up within their ice camp. We also use this coupled forecast system to look at coupled processes in the Arctic. This is just from a collaboration that we're currently working on. Where this is the impact of an Arctic cyclone. The yellow circle here is the Mosaic campaign location. The upper row is showing the atmospheric, the winds and atmospheric divergence. The middle row is showing ice velocity and divergence. The lower row is showing ocean currents and divergence. And we're using this model to look at the coupling, the interaction between the ocean, the ice, and the atmosphere as atmospheric phenomena, for in this case, a cyclone, passes over this campaign. And last, I just want to say a little bit about the work we're doing to support the development of the new coupled weather forecast system being developed in the US. It's not been really evaluated and developed in the Arctic. So we're developing that capacity to look at the coupling between the ocean, the ice, and the atmosphere in the Arctic using a single column model. And that's it's proving to be very important because it's never been tuned or evaluated in the Arctic. And then in this way, we'll be able to do that. And that is it. Thank you for listening.
Thank you very much, Amy. So the next presentation is going to be on capacity building and made by Penelope May Wagner from the Norwegian Meteorological Institute. Perfect.
Hi, can you hear me okay?
Yeah.
I'm just going to share my screen because I have a few slides.
Perfect.
Okay. I'm Penny Wagner. I'm at the Norwegian Ice Service, and I just want to say it's been really nice to see all these familiar faces and see new faces. So thank you for including me in this group. And I am, oops, can you see everything? Okay. Oh, there we go.
Yes, we can. It's working the slides.
So I'm a researcher at the Norwegian Ice Service, but I'm right now transitioning to oversee some of the operations to expand our portfolio to provide sea ice information for our users in the European Arctic. And as you see, we have a relatively small group, but we're always in a state of flux. So I think we're on a positive trajectory. So just letting you know, we are aligned with the WMO and IMO mandates. So similar to weather forecasters, our analysts put out ice information, and this is to support navigational safety. In my background, I've actually worked with the US National Ice Center prior to coming over here to Norway for my research. So I think that I have a really good understanding of how the different mandates and user needs vary between different ice services. And we also work very closely with the International Ice Charting Working Group. And you can see these are all very different ice services. So we actually work very closely together and work on different types of tasks together so we can really try to improve some of our best practices. And my background specifically was in remote sensing. Right now, we focus a lot on the more high resolution satellites, so synthetic aperture radar, altimetry, and of course optical, but prior to that was more scatterometer. So these are a lot of the sensors that support tactical navigation. So I will say that we do cater to many different types of users in our area. Since we cover the European Arctic, we have ship operators, we have those who, we service communities, we service those who want to stay far away from the ice, such as energy companies, and then research, of course. And we're involved in a lot of different research projects. Here's some recent examples of the previous and current European ones, but we actually have some other ones. And here's just some examples of some of the research that we work on. It's actually looking at the data assimilation and focusing on automated classification for automated products, and also looking at the data assimilation for sea ice forecasts. And sea ice forecasts are one of the main types of data and products that our users request. And so this is something that we're really trying to get a handle on how we can use all these really great services and products that are available and provide them in a way that all of our users can understand them. You can see actually what we try to do is really make some of this information visually easy to digest for different users. So we don't actually just give them a suite of information, all this information they have to dig through, especially when they're on the field. So we're looking at the sea ice risk index outlook, and also looking at iceberg forecasting. This is becoming very popular in our area. And we work very closely with the Greenland Ice Service as well. Yep, and that's all for me.
Thank you, Penelope. Thank you. So the last presentation of this first session will be made by Joseph Nolan from EuroGoose on policy and legal aspects in the Arctic region. I give you the floor.
Thank you. Hello, everybody. I also don't have any slides, but I'm Joseph Nolan, and I'm a science officer at EuroGoose, which is the European component of GOOSE, the Global Ocean Observing System, and the organization for coordination of operational oceanography in Europe. So I'm in this steering team as the policy and legal person, and I don't really have a technical background like everybody else seems to. So my background is as a physical geographer, focused primarily in the polar and alpine regions. But for the last several years, I've been working in kind of the interface between science and policy and coordination of science and other activities, particularly at a European level. With EuroGoose, I'm working largely in support of the Arctic ROOS, which is the regional ocean observing system for the Arctic, at least the European Arctic. And I'm supporting an international task team that's working to develop a Goose Regional Alliance for the Arctic at the moment, as well as various other activities with EuroGoose. Previously, I was a policy officer at the European Polar Board. So that's the organization coordinating polar, both Arctic and Antarctic research and logistics in Europe. And through that, I was working closely with lots of relevant organizations such as IOC, SEON, the Arctic Council, the Sami Council, etc., but also involved in various European projects such as Arctic Passion, which Michael will talk about in a moment. Also very much involved in EU PolarNet, and I was one of the coordinators of the EU Polar Cluster. So yeah, as I say, I've not really the technical background, but hopefully I can contribute with some expertise on the policy and legal framework in the Arctic through this experience at this kind of interface between science and policy, but also, you know, in a European context primarily, but an Arctic-wide context as well. And I think that's all I've got to say, so thank you.
Thank you very much, Joseph. So now we're concluding the first session of this meeting, and I'll give the floor to Eva Regan, who will be the chair of the second session.
Great, thank you, Barbara, and thanks to everyone who contributed to the first session there. So yeah, before the break, we will go a little bit deeper into maybe some of the periphery based things that are going on which can support us maybe, and then some of the end users where that we are hoping our forecasts can help or work with a bit more deeply. So we will start with a presentation about the Arctic Passion project that Michael Karcher is leading. So the floor is yours, Michael.
Yeah, thanks a lot, Heather. Let me share my screen. Okay, you can see it, and this should be the presentation mode. Okay, yeah, Arctic Passion is a large EU project which started in 2021. And its main focus is on collaborating with others of the community towards an improved observing system of systems for the Arctic, in contrast to what is there at the moment. As you will see very soon, it has a lot of different aspects we are tackling, but just a few basic numbers. So the project will run for 4 years. We have currently 18 countries participating, 35 partner organizations, and 6 indigenous communities who are part of our project. And those partner organizations, as well as the indigenous communities, come from Europe, but also North America and Asia. The coordination is with the Alfred Wegener Institute for Polar and Marine Research, and I'm the science coordinator for this. And if you're interested, have a look at our website. It's quite easy, arcticpassion.eu. So the basic idea how we set up Arctic Passion as a project is to serve certain needs which we and others identified before. There's certainly a need for best available data and knowledge to make knowledge-based decisions for Arctic decision makers. There's definitely a need for well-coordinated, user-driven, integrated observing system of systems, making data more easily available, making them more interoperable, and so on. There's also the identified need for a more holistic approach, also from the scientific perspective. That has become very clear in the past years, holistic in the sense that we need more interdisciplinarity, but also then beyond the scientific perspective need to be more inclusive of indigenous and local knowledge. And then one further aspect, of course, is the still strong fragmentation of the observing system in a similar way as it was presented before with the operational services or the predictive services. And one other aspect which is important for us is equity in access to and shaping of the observing system for all people. It is very clear that we are founding these activities on previous and ongoing international efforts. To mention one is the INTERROS project, which is a predecessor of ours, which was led by the Nansen Center. So what are we doing actually? We are enhancing instrumentation and coordination. We work on the inclusion of different knowledge systems. I mentioned indigenous knowledge and local knowledge. We are enhancing the functionality of the Arctic data system. We are developing a set of pilot services which provide user data or data for users for certain aspects, and I will show a few examples later on. We are piloting the shared Arctic variables concepts of SEON. I won't go into detail here. If there are any questions, I'm happy to respond to them later on or via email. Part of our activities is also developing societal benefit analysis or assessments, which are important to convince politicians and society that sustained funding of an Arctic observing system is very relevant and useful. We are enhancing international cooperation and provide policy and decision-making support with an own work package. And and then we are also contributing to a clearer and more equitable international structure for Arctic observing. So in a way, there are some similarities with the effort which was just described for this decadal prediction system. So coming up with a clear structure is really important. Just a few examples of our work. So as I mentioned, enhancing instrumentation and analysis is one of our activities. So for example, we deploy new multidisciplinary moorings in the Eurasian Arctic. There's a new sensor and instrumentation development for the marine sphere and the atmosphere. We deploy drifting buoys also for the sea ice and snow. We are building a unified snow-ice interface detection for ice mass balance buoys, microwave observation operators for sea ice, and improve monitoring of glacier runoff and calving front positions. So just a few examples. On the coordination part of things, we are supporting the Synoptic Arctic Survey, SAS, which is led out of the University of Bergen with our program. And also we are advancing the visibility of indigenous marine occupancy in locations, coastal locations around the Arctic, which can be found on the arcticseas.org portal. One important activity when it comes to the marine coordination efforts or improved coordination efforts is the development of a European Arctic counterpart to the Pacific Distributed Biological Observatory. We call it the Atlantic Arctic DBO. This is meant to set up a system which is able to identify key locations important for monitoring from an interdisciplinary perspective, and to make sure that there is enough interest in the community of seagoing nations to regularly visit those locations and take coordinated and coordinated observations using the same processes and protocols. As it turns out, and that may be of relevance here for you as well, there are 2 more distributed biological observatories in the making, with whom we collaborate, as well as with the Pacific DBO. and one is the East Siberian DBO, and another one in Baffin Bay, Davis Strait. And I think this could be a fantastic opportunity to link up between these DBO plannings and the prediction steering group, in particular when it comes to what is needed to identify the necessary observations for better predictions. Just to mention that there's also one decadal collaborative center submission for which our colleagues are just waiting to be decided upon. It has been submitted to the NSF, and it's dealing with the Arctic marine observations as a collaborative center. So that's another possibility to collaborate. A very quick run through our pilot services. We have one which is dealing with community-based monitoring using oral histories, indigenous and local knowledge, including several indigenous communities. We have one service dealing with permafrost and changes in the surface detected from satellites, which is an actual tool which is already online with some of its activities. There will be another service dealing with information on the state of the Arctic environment for different purposes. We are dealing with a service on improved fire risk management and one on local atmospheric pollutant forecasts in an improved way. One service is dealing with improved safety for shipping in polar seas. And then we have two more, one dealing with noise pollution in Greenlandic waters and one dealing with lake ice safety. So this is it, a very, very quick run through a few examples. And as I said, if you're interested, please contact me or have a look at our website. We have a blog where we provide updated information on what's going on. And I'll stop here.
Thank you very much for that overview, Michael. Okay, so before the break now, we have two stakeholder or user presentations. The first is by Lasse Rabenstein. So please, when you're ready, you can start your screen sharing.
Okay, hello. Do you see my screen?
Yes.
Okay, yeah, thanks for the invitation. I'm supposed to give a presentation about how we use forecast data in our everyday life. So I represent here our small company, Drift and Noise Polar Services, which is a spin-off from the German Alfred Wegener Institute for Polar Marine Research. And so I think most of the presentations before me were really high level. So I would like to go into the detailed problems in the everyday life of, for example, mariners. So I see the spectrum in this field of ocean data and ocean forecasts. The one pole is technology and science, and the other pole is really the user, which is represented here on the right side by the bridge on this expedition cruise vessel, the Commandant Charcot. And I think every one of us, our own company, every one of you is somehow located in this between these two poles. And the last years, since I've started Drift and Noise Polar Services with some colleagues, I actually have to navigate between these two poles. And the last year, I was listening a lot to captains and navigators and other operational persons to find out how we can improve actually information and awareness of ice for shipping in Antarctic and Arctic waters. And just some background on Drift and Noise Polar Services. We are a team of 8 people by now. We also have a little bit of fluctuations here. We are also supported by the European Space Agency. Presently, we have an ESA Incubed project to improve our app. The app is here in the lower left corner is ICC. But in general, what we're doing, we also consult all kinds of expeditions, research expeditions, and we're also involved in research projects, all with the goal to increase awareness and operability in ice-infested waters. I would now like, just maybe that's most interesting for you, to give you some examples from the work of the last years, how end users finally use data and what they need. So when I was asked to give this presentation, I was thinking about some unsolved problems so far. Maybe some of these problems can be solved already, because I see that there's already a vast amount of data available. Even after years, I found out about new parameters and new models which existed for years now, which I was not aware of. So even for me, being in this subject and totally devoted to ocean data, and so I found, after months and years, new data. So I think the landscape is already very complex. For the end user on board ships, this needs to be, the complexity needs to be minimized. And that's quite a tough job. So, but here are some examples. For example, I was talking to the fishing industry over the last years. Actually, one of the most complicated ones to convince to use more data on board and to invest in better visualization systems or in consulting. But so those ships have a certain ice class. They operate in Canadian Greenland and also in Northern European waters, close to the ice edge. And it happens actually, most fishermen tell me that it happens every time that at some point they have navigational problems in the ice because they get trapped in the ice. Here you see the position of a Canadian fishing trawler at the ice edge, and actually this ship was not really at the ice edge. You see here the sea ice concentration from the Alvarez sensor in the background. It was already kind of in the ice and not really in the ice edge, maybe in the marginal ice zone. And then it can easily happen that these ice situations converge, and then these trawlers can end up being trapped in ice. And here the question is, ice drift, especially the position of the ice margin, is very, very needed information. But of course, it still needs a person on board to make the right decisions. Here in the background, you see this is a screenshot from our app, how we translate the TOBAS 4 Arctic sea ice forecast system, especially the velocities in U and V direction into these trajectories of ice drift over the next days. But here, again, the question is, how accurate are they close to the ice edge, for example? So that's one example. So this here in this example, fishery would need hourly timescale predictions, probably. Ice pressure is important, ice edge location, and the consolidation of ice around the ship would be helpful. Another example is here in Canadian waters as well. This is Newfoundland, and we were sometimes, like this season, we were asked, and this is actually a complex question for us. We were asked, can we go through the Strait of Belle Isle, going back to Nova Scotia, instead going around Newfoundland? That's obviously an attractive shortcut for a lot of fishing vessels coming back from Labrador Sea, but they also call it the walk of shame, because if some of them is getting trapped here, then like there's a lot of shame on them, because that, of course, is communicated among the fishing industry there. So they're very careful in doing this. But that's just one example. So in terms of forecasting, like here you see, for example, the Strait of Belle Isle is open at some point. The ships have a certain ice class. In that example, actually, we refer to the Canadian Ice Service ice charts and gave the advice that this is not good to go through with the ice class ship they had through here, because following the Polaris Risk Index system, this was a clear red no-go. But it would definitely be of interest to see how ice in the Strait of Belle Isle would develop over the next hours and days. And with the present models, I think such narrow channels, for example, are not yet resolved. And another interesting example over the last years is from the Northern Sea route. In November 2021, there were a couple of ships trapped in actually young or like thin first year ice. These were ships which are not icebreakers, but they had an ice class, something like 1A or 1A Super or so. And they, most of the ships actually, I think, came from the Pacific side, and they wanted to traverse through the European side. This was the situation in October 11th, like here it's depicted on NASA's worldview in terms of CS concentration. And 10 days later, it looked like this. And obviously, this came with a surprise to some of them. And I learned that the CS concentration here is a problem when it becomes thicker than about 30 centimeters. So that's a question. So was there a reliable forecast predicting that they should actually not go and enter without icebreaker assistance now at end of October? Maybe it was already not a wise decision to go there, but that's definitely something where forecasting information would have been helpful. So it's daily timescales here, and the quantity of interest is the freeze-up time. So when is the freeze-up coming, and when will it reach a critical ice thickness? Here's another example from the Northern Sea route showing how quick, like within a couple of days, the ice situation can change. Here, this is from September 23, and this is from October 2. So a little bit more than a week later, for some ships, the Kitsky Strait here is almost not navigable any longer. So that's definitely a prediction which would be helpful, or maybe it existed, but it was not used at that point. If these loose ice fields, if they drift into this shipping lane or not. So it's again daily timescales. Ice drift of smaller ice fields would have been of importance here. One example from an Arctic expedition we joined last year when we were looking for the wreck of Shackleton's Endurance with the deep sea robot. That was also a very interesting application case for forecasts. So we had to operate this subsea submersible here in the Weddell Sea with mixed first-year multi-ice cover. And during the operation of this subsea vehicle, the ship had to drift with the ice. And that's why we needed the ice drift forecasts here in yellow and green. Each point is 1 hour into the future. So we always had to look that we positioned the ship in the right position within this green search box so that we drift according to the drift forecast in the right way, not to have a too large distance between the submersible and the icebreaker actually. Here in yellow, for example, we just did the nonsense rule of thumb drift forecast by the wind forecast from weather models. And in green, this was the consensus forecast by the SIDFAX model by the International Polar Year Project at the Alfred Wegener Institute. What we realized on the bridge, actually, this plot here shows the hourly position of the icebreaker over the entire surge. And you see when the points are next to each other, then it's drifting mode. And so in that example, in the lower right here, for example, we had predicted a drift in this direction, but then suddenly the internal oscillation, inertial oscillation started, and that confused a lot of people on the bridges, and it was not in the models, the inertial oscillation. So I don't know if that, I mean, in the end, the prevailing drift direction was still correct, but it caused a little bit of confusion with the distance to the subsea vehicle when this inertial oscillation started. So that would be interesting to have in a model as well, and very important also for navigating in the ice here where the tides, because navigation in low tide was definitely easier than in high tide, or it was the other way around. I can't remember. But that's as well something you can forecast very good, the tides in a region, but how that affects trafficability in ice is a more complex topic. Here is like an accuracy of how good our drift forecasts were during this project. So it's the directional error was in a 30 degrees angle, the mean error, and the mean distance to the predicted location 2 days in the future of an ice flow was mostly between 5 and 10 nautical miles, which was still too large for what the subsea vehicle actually needed. We found a solution to stay flexible and to work with the ice instead against the ice. But if this could be increased, of course, this would have been good to have like predict the position of an ice flow even better than 10 nautical miles 2 days into the future. Another research project where we need ice forecasts and ocean forecasts is we have a project which is working at the Google Maps of the Arctic so far. We're talking about route optimizations, and we are actually using classified Sentinel-1 star images here and move them by predicted drift directions and calculate through the drifting ice field an optimal route for a couple of hours into the future. And here, of course, it is of interest, like how, if you want to optimize a route on this high resolution on a radar image, then the question is, how should you predict how all these different ice types behave over the next hours and days? And so we came up with a solution that we just take the lower resolution model forecasts and animate the satellite image directly, as you see here. But of course, it's not very physical in the small scale. For example, this is a region close to Svalbard, and you would see that if the ice drift is in this direction, as you see here, then this polynia here will definitely close up, which is not the case with this method. So there is one challenge here is hourly to daily time scale, like including more small scale structures like open leads or ice pressure development over the next hours, which is probably a very challenging task, I see. Yeah. Okay, I think my 10 minutes are over. That's what I could tell you about using forecasting data from our everyday job. Yeah.
Thank you very much for that really informative talk about what we should be doing and why. Okay, finally for this section we have
maybe I can comment. There was a comment in the chat already. So
yes.
All I've shown is just what people and what captains of fish trawlers and so on reported to us. So I don't want to say all these are unsolved problems. So I see that the answer was that there is a Canadian model actually exactly for Strait of Belle Isle. And I absolutely acknowledge that there are solutions out already. But I thought it might be interesting for you to listen or to hear what our end users, what the people we are talking to communicate to us. So yeah.
Okay, thank you for your response to that question. Okay, finally we have Penelope Wagner talking in more detail about what the Norwegian Ice Service is doing and the links with the users there. So thank you, Penny.
Thank you. Let me just share my screen for a moment. Okay, if this is clear, great. Okay, yes. So thank you. So I'm going to actually talk. I'm going to actually follow Lasse's presentation. It's a very nice presentation, and talk more about how our users understand these ocean sea ice forecasts. And because we work with the Arctic, we actually primarily deal with sea ice forecasts. And my role in this group is actually focusing on capacity building. So I'm going to kind of shift between presenting on behalf of ice service, the ice service perspective, and then also some workshops and surveys that we've been a part of in the last recent years that actually have reports that come out of it. So I can just provide some of the summaries and also maybe go over some ideas of how we can improve on getting more increased uptake of users for CS forecasts. So I just wanted to briefly go over what we're looking at and what our perspective of the sea ice is. So I think when we're looking at the sea ice trends for the Arctic, we can see that, of course, there is a decline in the summer sea ice, but with also we need to really look at the decline in the winter sea ice. And this is important because we need to look at where the areas are at. We can see that there's a huge loss of sea ice around these peripheral zones. And particularly what we're noticing in the last between 5 and 10 years is that we're seeing that a lot of these sea ice regimes change. And these changes are affecting how our users are making decisions. It's actually affecting how we monitor sea ice, and it's affecting what types of products we can use for this. And when we say the ice-free Arctic, when this term is used, when it comes to operations, this actually still means 1 million square kilometer of sea ice, and it's always going to freeze back in the winter. And this first year ice is becoming a lot more difficult to monitor with the current suite of satellites that we have. And this really does affect how we use the models and how our users understand the models. So this matters is because we need to understand why we're seeing these changes and what we can prepare for. We need to figure out how the models can keep up with that. And actually, I just added the slide because Lasse did a very good job in presenting some of the complexities of what our users are seeing. Now, this is the current state of the sea ice. And as you see, these are just snapshots of articles because a lot of this is anecdotal evidence. It's not often that you'll see a lot of users publish papers on some of these changes they're seeing. So we really have to go out and talk to people. We have to be on the ships. But this is very resource intensive, and it's really difficult to get a lot of the quantitative data. But we are seeing this, and we're observing this. So I want to talk more about users. I'm supposed to present on users and stakeholders, but I think it's not so easy to say the users are end users. We consider ourselves users. From our Kepler project, that was focused on user needs. We have different types of users, which are data, information, and knowledge, and we consider ourselves information users, so information providers. We would like to use these different types of forecasts and models and provide them to our end users, which would be the knowledge users. But you see, sometimes it depends on who you are. Like these roles can shift quite often, and it's not very linear. So we, as us being a public service, we have to be very mindful of what type of information we send out. We can't send out something that's too complicated. We have to make sure that we align with very simple, basic descriptions of the data, which is it has to be relevant. We would like it to be as similar to the current conditions and representative of the conditions that our users see when they're on the field. It has to be reliable, so our users have to know who to call or how to access information or ask questions if they're in a situation. And overall, it needs to be accessible. Again, a lot of people, especially when you're on the field, you don't have the resources to or the time to actually look at different type of information. It has to be the correct one you're looking for. And I actually put this out. This is from the International Ice Charting Working Group Mariner survey that was done in 2019, and also as part of the Kepler project, but in conjunction with this group. But there's a lot of factors that are relevant to how users make decisions. It depends on their skill set. It depends on the ships that they're using, the ice class. It depends on their level of training. It depends on where they're at, in what area, during what season. There's such a high seasonal and regional variability with sea ice that these are very important. And also the types of users that travel in certain areas. We know for a fact that those who are driving icebreakers have probably a very high level of understanding of sea ice, whereas those maybe who are outside of the sea ice and can sometimes come into these areas because of prevailing weather conditions, they may have a different level of training. And then whether you're in the ice, whether you're in the planning stage, or whether you're trying to stay away from it, it depends on whether or not you need tactical or long-term type of information. So we know that our users use all of this, and they're all very valuable. So this is actually, we've done a lot of surveys, and this is from the ice service perspective, but what we've seen collectively is that primarily our users want information that's high resolution, that they want different types of forecasts, so short-term to medium to long range, and it has to be reliable. This is a very common element to this. And then, of course, as you see, this is they have to be accessible. And now these are just this is just a summary from the survey that was done in 2019, which had 98 respondents. So I think this is a kind of a really good overview on how users understand sea ice. And then on the right-hand side, you can see this is the same for icebergs. They want to understand the risk. They want to look at this for situational awareness, and this is where forecasts can really help out. So there's another component from as part of our EU Horizon 2020 project Kepler, when we're actually looking at how users and information providers understand sea ice forecasts. So we're trying to kind of map this with the forecast producers and then also the forecast users and try to find some of the major components that are important to both. So some of the issues with this is that the forecast quality is highly scale dependent. And we know that the longer that it goes out, this affects the spatial resolution, this affects some of the quality of this. Now, normally on average, a lot of the users have requested sea ice forecasts on a more tactical level. So this traditionally makes a lot of the numerical weather predictions not suitable for that. However, they are very valuable for looking at, for providing information on strategic and a more long-term planning level. And this is something that, I want to say that a lot of ice services don't normally use off-the-shelf ocean forecasts or models because they try to assimilate them using some of the input data that is similar to what their users want on the tactical level or what's produced in the ice services. And then so from the Arctic Frontiers in 2018, there was actually 2 concurrent workshops focusing on sea ice forecasts that incorporated users as part of the side sessions. One was one that we led, which is the ASAP-SW, which is the Arctic Sea Ice Forecast Prediction workshop. But we actually had those who were modeling, who were developing models on the short to long term. And also we had users from the fishing industry, from polar tourism, from the energy. And on the other side, the Salient Seas project was looking at seasonal forecasts and how people understand them. So what we found out, we actually didn't talk so much about what users wanted in the forecast. The focus was mainly more on co-production. And it was actually, we find out that similarly, that we just kind of speak different languages. So the overall recommendation is that there needs to be a lot more collaboration and cooperation in the development stage of these different types of models and forecasts, and really get the user input. Sorry, can you hear? The user input integrated in this in the beginning rather than at the very end. And we do need to use the same common terms and terminology so that there's an understanding, and this can be a lot more, the interchange is a lot easier for these. And then we also did an online workshop as part of the High North Dialogue that was supposed to have been in person, but we had to do it online because of COVID. And it was actually focusing on the user needs for sea ice forecasting for navigation in Svalbard and the high Arctic. And this consisted of modelers from the US, the UK, and a few from Europe, and those from the maritime authorities in Norway and some in the Baltic area. And so we actually had a white paper that came out of this. And what we overall wanted was that there was more detailed about these different areas that the users are going in, that Lasse demonstrated in his presentation. But the forecasts were one of the most highly requested sources of information. And they want to actually understand how we can translate the climate model outputs into products to help provide decision support, because we know that this information is out there, but there's just really a huge gap for this. So some of the major overall report recommendations, you can see it's not really talking about the different types of resolution. We're actually talking about really communicating these models and forecasts into metrics that are understood easily for the general public. And there's also another component of recommendations for researcher and product developers, is that we try to actually establish some more formal cooperation opportunities. I know it's easy to say that we should work together in the beginning of projects, but how projects go is that, I mean, there needs to be some type of mechanism that allows people to not only provide in-kind support. This is very difficult to get people to provide in-kind support. So I think there needs to actually be more of a systematic way of getting different groups together and having a more sustained dialogue. So maybe really actually having the users, different types of users, be part of these types of project development funding. So just to end my presentation, from the ICE service perspective, the ideal ICE service that we would have is that we would provide a lot more frequent updates with more information. We would like to provide tailored services, but this is, again, resource intensive. So it is ideal that we work with a lot of these more private and third-party companies so that we can add value to both of our services. And we really need to increase our product portfolios on providing more information so that we can do risk assessment and the users can have more of a situational awareness for the sea ice and icebergs, and that the information has to be scalable. So I think it's really important that we know that we have to serve many different types of users for many different types of seasons, and that the operations are going to just get a lot more dynamic. And that's my presentation.
Thank you very much for that presentation. And thanks to all the speakers in this session, which gives us a lot of things to think about and how we can work with other things going on slightly outside of the OceanPrediction DCC setup and direct forecasting systems to hopefully move forward in a constructive way. I think it's time for a quick break now. I would say to give us the 10-minute break, we can come back at 4:05, UTC +2, that is. So in 10 minutes time, 5 past the hour, whichever the next hour is for you, when we will have a session 3, where Enrique will be leading an interactive activity. So see you in 10 minutes. Thanks.
Hello, everybody. We're starting in 1 minute. So thank you everybody for being here. We are only 10 minutes late with respect to the expected time, and this session will consist in 2 parts. First, we will do some game. We will play a little bit. I hope you can connect to Slido. You have here the web and the identification to enter into the poll, and we will go through a series of questions, and then we will leave some time for questions, for your comments. Also, if you want to comment something on the terms of reference that we have wrote for this group, it's the opportunity to do some comments to serve to improve these terms of reference. Anything you want to comment will be later. So let's go now first. I hope we will have a nice time with this. It was very successful in other regions. Let's go with the first question. So first question is, which are the main applications that ocean forecasting is having today on the region? So please connect to Slido and use this number 34568. Very difficult to remember, to enter into the poll and type your replies there. We have a first one, support to navigation, that fits with the presentations we have had. Very, very nice presentation, by the way. I think it was really great to have not only the forecasting side, but also the user side onto this meeting. Remember, we are here to try to build a community that should go beyond the purely technical thing. This is kind of challenging for us, at least it's been for me, because we are used to work always with the same people, more or less, since so long. And it's very easy to contact the friends on scientists that have been working with you in European projects, in many different things, and to build something with them. But now we have to think out of the box, and we have to try to attract other people to our community, people that will enrich the conversation and people that will show very nice things like the ones that were presented today. So we're having some more replies. Climate impact on local and indigenous communities. That's really a good thing about the regional teams. Sometimes things are popping up that you could never have imagined from your ignorance at your region about other regions. Ice pressure and diurnal drip variation. So used within coupled weather forecasting systems. So this is a very interesting technical thing, how the importance of coupling with weather forecasting system. Eddy resolving capacity. So this links to the nesting, to the high resolution modeling, environmental emergency response, which is somehow linked to a certain point to support to navigation. Climate change impact and planification for adapt, very important, of course, especially in this region. Sea ice impact on mid-latitude weather, and local and regional planning. And I think there is a problem with one of the replies because it's split in several words. I don't know why. It's probably I can reconstruct sea state, storm surge, coastal erosion. Those are probably the impact on ecology, governance for sustainable development. So if we have to look for different categories here, One is, let's say, the classical applications of this kind of ocean forecasting. This is sea state, storm surge forecasting. Then there's a lot of inputs related with navigation and search and rescue, with all the activities at sea related with navigation. Climate change will be a third category here. So I can see basically these three categories plus some other things like governance for sustainable development. This is an important one because we want our system to be influential in the governance for sustainable development. So thank you very much for these replies. I think we can go to the second question, which is, which are the main gaps for ocean forecasting today in the region? So here you have to talk as expert, as scientist, and also as a user. I want to mention that we recently did a survey in both for users and for scientists on our systems, and it is very interesting results because the scientists, we are very, very critical. We are not very happy with the systems, while the users are more happy than us. The users are more mild with the critics than we are with our own systems. Maybe it's because for us precision is very important, and for the users it's more about kind of semaphoric condition, if yes or not, depending on the certain thresholds. So maybe to know that it's 8 meters or 6 meters, a significant wave height is the same for a user, but for a scientist it's a huge difference in the models. So we have here some comments on the observations. That's not strange, especially in that region. I'm certainly not an expert on observing on this region, but I guess if observing in our latitude is very difficult, I can imagine that it's even harder on the Arctic. And then we have many things popping out now. Sparse in situ observation. Again, models are biased. Okay, so this is problem with the modeling system, with the forecast discrete feature floodlets. I don't understand very well this one. Ice dynamics and morphology evolution. I guess that this is not very satisfactory. Ice thickness distribution model. Again, I guess this is not satisfactory. Again, observations. Freshwater fluxes. I guess this is very relevant in everywhere, but probably here it's more than in any place. But freshwater fluxes is one of the gaps that we all have on the ocean forecasting today. Utilization of computer power data volumes, uncertainty of estimates. Well, that is very nice to read, because we have the systems running, but it's always difficult to know how accurate our forecast is. Uncertainty forecast should be accompanied with uncertainty estimates. So this is a good point. And missing interoperability of observational data. Okay, scale, probably smaller scale features. Again, this is broken, I don't know why. But again, we go to the resolution problem. So I can see a lot of things related with problems on the capability of the models to solve properly the physics. Something related to the resolution, something related to the capability to the bias of the models, things like that. And then we have a lot of comments on another family, is a lot of comments on the observations. And this is basically it. And then I have a few ones that are out of these categories, like utilization of computer power data volumes, which I don't understand very well. If there's, let's say that there is difficulty in accessing these kind of resources, I guess so. And then we had some comment about our Russian colleagues, which is obviously difficult to work with them in the present situation. Lack of information on quality. Again, this is linked with the uncertainty. So very nice. I think we can go now to next question. Please continue writing replies on the other ones if you want if you have had no time. It will be on the final report that we will prepare by the end of the meeting. So we want to use all this to prepare a small report at the end of the meeting. So the next question is, which are the activities you think OceanPrediction DCC should focus to improve the situation of ocean forecasting in the region? So help us, this question is, help us to steer our activity, help us with your ideas, help us with your guidance, to let us know where we can be useful, in your opinion, in your region. So how can we develop an activity that is useful? You know what we are trying to do. We have technical activities. We are trying to do this definition of architectures with tools, standards, and best practices that will improve interoperability. We also are working with capacity development and ocean literacy, and yeah, you know, interact with Arctic Passion and other observation programs. That is certainly a very good one. I really liked the presentation on Arctic Passion, and I think there's a lot of, as the presenter said, there's a lot of commonalities between Arctic Passion and OceanPrediction DCC in many aspects. Only that Arctic Passion is focused on observation, and we are focused on forecasting. So ensemble forecasting, that is a need. I think what we can do there is to work on the definition of the tools that should be built to do this ensemble forecasting, but we are not ourselves, let's say, an operational agency, and we are not obviously doing ensemble forecasting, but we can support that the teams at the Arctic region could develop ensemble forecasting in a more robust and easier way. This is what is about the DCC, to guide the teams towards the technical solutions. Then we have advocate for best practice across continents. Perfect. This is exactly very tuned with what we are planning. Coordination of existing ocean forecasting systems. Perfect. Model data and in situ data information laboratories. Well, I don't get this one 100%. I insist we are not, let's say, an operational team. We are about providing a recommendation. We are providing standards, tools, and best practices to the teams so they can develop their systems in such a way that interoperability is improved. Same comment for coupled atmospherized wave ocean modeling. So this is obviously the future of ocean forecasting. Forecast compared to better understand uncertainty, very related with ensemble forecasting. So it looks like coordination of existing ocean forecasting system. It looks like there's a real need of some kind of action towards the communication of the forecasting systems, because there are many things about linkage between user groups. Exactly, in the that was what I was trying to explain. Linkage between forecasting groups, in this case, not user group, between forecasting groups, and we have now this other one, linkage between user groups. Again, we have another one which is splitted, and we have a game of reconstructing it. Real-time in situ observations, enhanced real-time in situ observations. Well, again, our role here should be to highlight the importance of real-time in situ observation for ocean forecasting, and by doing that, we hope that we will be able to promote additional money for observation and additional coordination for observation. So I think this is it for this question. It's very nice replies. We can go to next one, please. What kind of capacity development and ocean literacy activities do you believe are needed in the region? And I think that this is very important, but also I like to think on a region like the Arctic as a region that can contribute to our activities in other regions. So think also in the connection between the Arctic and other regions, and how can you, let's say, think that these ocean literacy and capacity development activities are needed in general. Improve mariner used knowledge of sea ice. Okay. So that is very much to the core. Joint development by scientists and end users. Okay, this is co-design, I think, more than development. I think this is joint co-design of the products, because the development at the end of the day should be done probably by the scientists, but the design of the systems could be co-designed. Reach out to international students, also Russians, again, difficult at this moment. Modeling capacity with Arctic communities. Modeling capacity within Arctic communities. Okay. So this is interesting because I had a feeling that maybe that was not that needed, but expressed like that, it means that capacity development, it does not only apply to let's say, less developed technical countries, but you have the feeling that it is needed also within Arctic communities. Indigenous engagement training, that's very nice. And again, something that is way beyond my experience. So this is why the idea of the regional teams is so nice, because you can bring activities and you can bring ideas that we could have never delivered from Toulouse. Help educate to understand forecast and limits. That's a good one. We need that one, certainly. Community-based observation. So it's, let's say, kind of citizen science observation or something like that. Citizen science-based instruments, very much related to community-based observation, in my understanding. Useful forecast and uncertainty metrics. So again, this is about teaching us how to work on the metrics and how to communicate uncertainty to the users. So very, very nice inputs, and this will certainly help us when building our plans for capacity development. Thank you very much for all these inputs. So next one and final one is about, do you think observation from the region, if available, are sufficient to constrain the ocean models and produce a great forecast? If not, what kind of observations are we missing? So you see here, we see the observations from the point of view of the ocean forecasting. We are asking if the observations are sufficient to constrain our models, basically to initialize our models, to do the data simulation process. And if we don't have enough observations, what kind of observations are we missing in this task? So it's not a, let's say, general question about observation, but it's a question oriented. It's a question related to observations, but oriented to the ocean forecasting. River runoff, in situ sea ice thickness. River runoff is a constant everywhere. And it has been a constant for the last decades. Every time we meet and we think what is missing, it was river runoff and bathymetry, and more is river runoff only. Bathymetry seems to be improving a lot in the last decade, but river runoff is still always present when you are talking about gaps. In situ under ice observations, that must be difficult, but yeah, I can imagine that there is a huge gap there, because if it is difficult to observe without ice, I cannot imagine with ice. Autonomous, wow, we have really difficult exercise here to reconstruct this one. I can get it, that one. We know nothing of the currents below the ice, so again, observations below the ice, very linked to the previous one. Temperature and salinity profiles, autonomous observation of the water column, I guess it is. So, yeah, again, linked with the profiles that were mentioned. Temperature and salinity profiles could be linked to this other comment on the water column. Remote sensing observation, that could be HF radar, and I guess sometimes satellite observations. Again, I'm not an expert, but sometimes satellite observations are having problems, well, are not existing in high latitudes because of the orbit, of the inclination of the orbit. So I guess this is a problem for remote sensing observation of certain variables. Under ice observation, Central Arctic, okay, that's not strange. Again, could be very much linked with the lack of remote sensing observation because of the orbits of the satellites. In situ sea ice thickness. So basically, we have problems observing the ice itself, the thickness of the ice, the snow thickness, the sea ice thickness. We have a lot of problems to observe under the ice, and we have problems to reach the Central Arctic and to have remote sensing remote sensing data. And of course, no observation is, oh, sorry, it's a pity that some of the, I don't know why this is happening, some of the contributions are breaked into words beyond possible reconstruction. So we will try to do the game later to reconstruct that, but it's impossible here. But I think there is a clear map. There are difficulties to observe the ice, the central part of the Arctic, and what is going under the surface. So in this case, I can tell you that this set of replies is very, very different from other regional teams. We are playing the same game, and this is normal because the Arctic is completely different from the other regions we are dealing with. So this is why it is again nice to deal with the regional teams. So this is it. We will try to reconstruct a little bit this mess of words, especially on this last one, and we will try to include all this on the minutes of the meeting that we will deliver. So with this, we complete this interactive session. I hope you found it interesting, and I will give you now the floor for any comment you might have, any doubt, any suggestion, any question on the philosophy, on what we are trying to build here. So please, if you have some comment or some question, or you want to say something, raise your hand and I will give you the floor. Michael, please, the floor is yours.
Yeah, thank you. I find this a really useful. Oh, sorry. Can you hear me now?
Yeah, perfect. Thank you.
Okay. I have to get closer to the microphone. So yeah, I think this is a really useful exercise, what we are doing here, or what you have been organizing. So if I understand correctly, I see three main let's say columns or elements which need to be tackled. So the central one is the actual technical issues. How is prediction going to be improved? How are the different prediction centers are going to interact with each other to harmonize their approaches and so on? And then you have the input side and the output side on the other two sides of this central column. The output side was discussed partly. So how are the products going to be presented? Are they fitting to the user needs? Are the users educated enough to understand what is provided as kinds of results? And then on the input side, and this is more what we are coming from with Arctic Passion, is what are the data which you actually need for doing good predictions? And of course, the requirements will be very, very different depending on what kind of predictions you are doing, what scale, what temporal scale, what spatial scale, what region, and so on. But I think it's really necessary to establish a kind of mechanism where the observational community can communicate with the prediction community in trying to, when plans are made for future observing system elements, that the predictive part is integral to those considerations. So that's just my pledge here, that we really try to establish some kind of longer term interactive, I don't know, working group or platform where we can interact on these things.
Okay, first, thank you very much for your kind words about this exercise, and I fully agree with you on the importance of the linking between the forecast world and the observation world. And in this sense, we are doing a very first step, and if you want, a small step, because there is a lot of work ahead of us, and we will not see this work finish. But in the technical pillar that I was mentioning, in the ocean forecasting co-design team, we have experts for all the different aspects of the ocean forecasting value chain. And in particular, with respect to the link of observation with ocean forecasting, we have Pierre leading this particular contribution. And the idea is that we will start soon generating material. First, we are developing a state-of-the-art, let's say a present-day situation. Second, we will develop a gap analysis. Third, we will develop, well, we have a development in six steps, developing step by step these contributions. And the idea is that once all this starts to flow, we will provide it to you, to the technical, to the steering teams of the regional teams, to hear from you, to check if you want to, let's say, contribute by smaller things, or if you really want to jump into doing some real contribution, you can be one co-author of what we are preparing, and you can jump into the team. So the idea is that we are creating now these steering teams, and once we start producing, and this will happen hopefully very soon, material from the technical part, I think that in 1 month we will start having something to share with you. We will start sharing this information with the steering teams to hear about you, so you can comment, correct, add, or if you are really pushing forward and you have a lot of things to say, you can become one of the co-authors of this work. So this is a very first step, what I can tell you. And on top of that, I agree on everything what you have said. I hope this is satisfactory for you. So next is Gregory.
Yeah, you hear me okay? Yeah, so I just wanted to add a sort of a perspective following on from Polar Prediction Project and YOP. And I mean, through the 10-year program, we talked about a lot of these similar issues, and actually there's some materials there that could be useful in terms of the implementation plan of the Polar Prediction Project that discusses various different challenges to forecasting in polar regions, and including the Arctic, of course. And also touches on service side issues. There's a big focus on ice services, navigation, things of that nature. And this is in addition to other efforts outstanding. So earlier we heard mentioned the activities from the International Ice Chart Working Group. So there are already a number of existing efforts that look at connecting to users in the Arctic, user needs, how to use the forecast and whatnot. And I think one thing that's important to take into account in all of this is that the state of the Arctic is a moving target. So there's the way the Arctic looks now, and there's the way the Arctic's going to look 10 years from now, which is probably quite different. And so I think we need to think about that in terms of the way we're looking at our forecasting systems and the way we're looking at the observing system we want. And in particular, taking advantage of, in a way, the fact that we expect there to be much smaller ice coverage seasonally. And so this really brings out the importance of the ice-free areas of the Arctic. So in the past, a lot of people think about the Arctic, they think about sea ice, right? But the area that's actually ice-free now is much larger. And so the importance of, standard products that we use globally, but are of perhaps questionable quality in the Arctic. So we think of here, for example, sea level anomaly data that depends on an accurate mean dynamic topography, which is well developed in the Arctic. Sea surface temperature analyses, which can be affected by the ice cover. The in situ data, which is despite Argo being a global array, it doesn't include the Arctic. So we have a real gap there. So there are a number of these sorts of things that I think are very relevant in terms of having a kind of a new focus on the ice-free areas of the Arctic, which is something I think that hasn't had as much of a focus as the kind of ice services area, which of course will still continue to be important, especially as we have a more dynamic ice cover and more people are trying to get into the Arctic and skirt around the ice. But I think there's real scope for a focus on the ice-free areas of the Arctic as well.
Yeah, thanks, Greg. I think this is also relevant to demonstrate the importance of this regional approach. You are describing a situation which is obviously very, very unique for the Arctic, and with a lot of also implication on the way the waters are being used, for example, for navigation. So it has a lot of connection with the uses of the waters and the uses of the forecast that we are providing. So it makes a lot of sense that what you're saying is part of the vision of this particular regional team. And in this sense, I want to stress that somehow I would like that the regional team have a little bit of, let's say, independent life by themselves. I would like them to be strong teams able to launch things that are born inside the team. That will be a great thing to get with time. I think we cannot get this during this year, or maybe not during next year, but with time we can approach to this additional way of working with the regional teams. So, do we have any more comments or any more clarifications? That, in this sense, I want to highlight that, as I mentioned, this year is about building this community, is about starting to move slowly, I will say at the beginning. So don't expect, let's say, a huge demand of work for the steering team during the first year, because we are very occupied in building the whole structure. And we hope that when the whole structure will be in place, we will slowly start speeding up the process. I think that the first thing that will come will probably be this interaction with the co-design team in order to support the co-design team in getting the best recommendations for this architecture. Some recommendations that will fit the needs and will fit, for example, the vision. This is the place, Greg, where you can drop this vision into the documents, and we can make sure that this is contemplated, this changing target, as you call it. So, friends, if this is, dear friends and colleagues, this is it. If there's no more raised hands, I would like to thank you. Maybe we can connect the cameras for a quick picture for the history. And really, thank you very much for your participation. Thank you for being here. I think we finished perfectly on time, if I am correct. Surprisingly perfect on time, to the minute. So I think this is again unique for the Arctic. We never got that in the other regions. So thank you very much to all of you, and let's stay in touch and let's start working here. Thank you very much.
Thank you.
Thank you.
Thank you. Bye, everyone.
Thanks a lot. Bye-bye.
Thanks a lot. Bye-bye.
Bye.